Welcome back, AP Stat students. So we've got our fourth question from this exam. So consider an experiment design here. So quick to review what a treatment is in this case would be, they didn't say, did they? Okay, they're just showing how to assign them. So the treatment could be, could be a pill, where there's an active ingredient and a control group might just receive a placebo. Now, with the way they're assigning these groups, this is pretty typical. So you would coin flip, um, heads would get the treatment, tails would get the control. So I think that's what they said here. Let's see, an outcome of tails assigns a person to a treatment. Okay. So for this, it looks like if you get arrangement A, the first flip was a tail because man 1 is in treatment. Now, man 2 gets the second flip. That looks like that person for arrangement A was also tail. And then they wanted to make sure that they just assigned the remaining people into groups. So as soon as those two were assigned, then they just put women into the control group. Now, this is different for arrangement B. What happened was the first flip was a tail to put the man 1 in treatment because they said man 1 will be flipped for first. It must have been heads for the second flip because now man 2 is in the control group. So they did have to go back to the coin flip now for a third coin flip for this one. Okay, so they must have flipped tails to assign this person into the treatment group. And then they just, whatever remains, they just put the, whatever spot is open is what they put woman 2 in. So it looks like we'll never flip for woman number 2. We'll flip for woman number 1 whenever the men go into different groups, it looks like. Okay, so this one started out tails, heads. Then it must have been heads because woman 1 got assigned to the control group. So, and then we don't even flip for the last person. So that's kind of the arrangement. Okay, down at D, what it looks like is it went heads, heads, because both the men are in the control group and they were flipped for first. So then you just place the other two women. You don't actually have a third coin flip. So it looks like when the two men are in different groups, there will be 3 coin flips. When they're in the same group, there will only be 2 coin flips. All right, let's see. Probabilities. Okay. So for A, what was it? It was 2 tails. So the chance of that, 2 tails in a row is 1/4. The rest of them was 3 coin flips. And I guess the outcome really doesn't matter because that arrangement exactly is 1/8 of a chance of happening. Then they went back to D. There was only 2 coin flips. So that arrangement, I think that one was heads, heads. Okay, so that was 1/4 of a chance of happening. This is back to an 1/8 and an 1/8. Okay, go ahead and investigate that more on your own if you need to. Now, if we do it right, that will add up to 1. It does, 100% or 1. So that's it. What's the probability that man 1 and man 2 are assigned to the same group? That's 50%. So I'm going to say 1/4 plus 1/4 is 1/2. So there's that. Okay. So for A, I know that I went through that quick. That actually, for me to do that, actually took about 5 minutes to decipher what was going on. So don't expect to do that as quick as I just did. Okay. It should take you about 5 or 6 minutes to do that part. And remember, we have 15 minutes for this year's AP exam, 2 questions. We have 15 minutes for one of them, 25 for the other. So 5 or 6 minutes to get an essentially correct, right? That's how they're going to score it. It's E, P, or I. I means it was incoherent. It had nothing related to the course, okay? Or just so far off, we can't give you any credit. P means it's partially correct. There's a big range, wide range for P's. You're going to get a lot of those, and that's great. You're going to score some points with a lot of P's. An essentially correct of course, is what we're looking for. It doesn't have to be perfect. It just has to communicate enough of the course content and be close enough to what is expected to get the E, essentially correct. So both of those would score an E, or they might just combine for one score of an E. Depends on how they break that question down. Okay, so the same 6 arrangements could happen for part B with a chip method. Now this one is everybody pulls a chip basically out of a hat. Okay, so this one, to break it down more in depth for you, it's basically there's four people to choose from. Choose 2 of them. So it's 4 choose 2. Okay, so that's, if you know combinatorics, 4 choose 2 is 6. So there should be 6 outcomes, but in this case they're equal. Okay, where what you see up here is each of these outcomes is not equal. Okay, so this did not fairly distribute that, and in fact it favored something we really didn't want. We don't want both men in the treatment group if they have some common characteristic, that's going to make that, that's going to make a difference there. So if gender has anything to do with this, if gender is a confounding variable, this experimental design isn't going to be good. Okay. Now replication, of course, is not done either, so it fails on a couple ideas for well-designed experiments, but that's not the point. I think this is a probability question more than anything. Okay, so for the chip method, it's basically equally distributed. Okay, so all of these have a probability of 1/6. Okay, so that's the main difference. Yeah, so they all have the same, each of these arrangements have the same chance of happening. All right, so what happens here is this. For this way of choosing, each of these basically has 4 possible arrangements, all 6 of them. So, so there's basically 4 factorial ways for this to play out, which is 24. Okay, so each of these different arrangements, there's 4 ways that this could have been pulled. Okay, so man 1 and man 2 could have pulled the treatment cards, but they could have been in different orders. So let's say you had a green one and a red one. Okay, so man 1 could have pulled the green or the red and been in this position. So that's 2. Woman 1 could have pulled the green or the red and still been over here. So that's 4. So there's 4 ways for each of these to happen. Now, they don't really care how the arrangement is. They just care about the grouping. So that's combinations. 4 choose 2. There's 4 people to choose from. Choose 2 of them to go into the treatment. And then, of course, the other ones just fill. So if you happen to choose both the men, the other 2 are women, and so on and so forth. So each of these has a 1/6 chance of happening, all equal chances. So what's the probability that both men are assigned to the same group? This time it's 1/3. Oops. Okay, so there's another E that we could have gotten. All right, knowing what happened in the beginning parts where it was the coin flip method did favor having the men in the same group in that case. So we want to avoid that. It looks like, to be more fair, to be more equally representative, it was going to be the chip method. So I would say the chip method's probably better, and here's why. You have an unequal number of teachers and students. If you assign the students first, okay, let's say the coin flips happen to go, let's see, even 7 out of the 10 students are assigned, let's see, to the salad, right? Well, now only one of the remaining teachers can have a salad. And now we're going to have an unequal number in the grilled cheese area. So you're going to end up having 5 out of 6 of the teachers in the grilled cheese sandwich because of how the coin flips started out. So we want to be careful of that. So make sure that instead of the coin flip method where now you could be overrepresented by the teachers in one of the two, let's just do the chips, pull the chips, and hopefully it's a closer to equal representation of both the salad and the grilled cheese. So I'm going to go with the chip method. Okay, so it looks like if we use coin flip method, the group that is flipped for first has a higher chance of being over let's see, being not even so much as the group that's flipped for first. But it looks like they're placed together a little bit tighter. So being placed together, which then leaves the other group to be overrepresented together. Okay, basically, so if the heads or tails for the student is not equal, is not close to equal, there will be one group that is overrepresented for each of the lunches. Okay, so we want to distribute them more representative of what they are. 10 students, 6 teachers. We want them to randomly get the salad or the grilled cheese. What we don't want is we don't want to have 3 students get the salad and 5 teachers get the salad. That's not how we want the random assignment to come out. And that could happen in the coin flip situation. So yes, we want randomization, but we want to be careful not to have randomization that does not represent the same proportion as our population here, okay, as our group. So hopefully that's a very tricky part C. It's tough to get the full credit on that, but at least give it a shot. All right, try to recognize what's happening earlier and how that might impact what happens in part C. All right, hopefully this was helpful, and good luck on your final exam.